So if you remember, the automaton game is one proposer making a take it or leave it offer, and the other deciding to accept or reject, and depending on the acceptance or not, the outcome is determined. One possible reason is that fairness and trust is very important in the society in general. So at some sense, economists don't believe that. So George Stigler has this famous idea that self-interest wins in the end. When you get an unfair offer, you say, hey, I get only $1, you get $9. Well, what does this mean? This means that you're willing to forego $1 for 9 times of damage of this unfair proposer. And so this gives you a price tag. Oh yeah, so 1 to 9 is the relative price you're willing to pay for revenge. One of the interesting examples of this in the American history is during the founding of the United States of America. They were discussing, well, they started out with only 13 states, and they anticipate more states to join in. And so their question was, should we allow the same equal voting rights to the new states who come in? And as you know now, the United States of America has 50 states. So the initial 13 states have been outnumbered. George Mason said that they will have the same pride and other passions which we have, and will either not unite with or will speedily revolt from the Union if they are not in all respects placed on equal footing with their brethren. So there was this argument that they said that it's this fairness argument that founded the United States of America, decided that we will give all of the future new coming states equal rights. And in fact, nowadays, because there are 50 states, so both in the Senate and in the Congress, well, the initial 13 states are definitely outnumbered by the newcomers. And of course, one problem you can ask here is that, is this fear of rejection, or is this pure fairness? Because there is mentioning about, oh, so if we do not give them equal rights, then they will refuse to join us or decide to revolt and leave. At some sense, this experiment illustrates the first principle or first assumption you see in economics, which is self-centered or self-interest. Why are most of our why don't most of our utility functions that we teach or we use not include other people's payoff or other people's consumption? It's only my own consumption or my own payoff. Well, I still only care about maximizing my own utility. It's just that, well, you're my friend, so or she's my daughter, so I'm willing to put his or her welfare into my utility function. I'm still self-interest in the sense of I'm maximizing my utility. It's just that my utility function includes my family or my friends. Well, okay, so there's one problem for actually doing this if you actually, in standard economic models, which is the first welfare theorem will actually fail. Yeah, so one thing, or if you remember what the first welfare theorem is, it's that a competitive equilibrium is efficient. Well, that's the first welfare theorem. But to establish that, you need several assumptions, and one of them is that you only care about your own consumption, not other people's consumption. And so there is a mathematical reason why you don't see that kind of other regarding preferences anymore. And then we go to the public good game. One of your colleagues asked me about experiments on public economics, and the first and foremost is the public goods game. And then we'll look at ultimatum game, dictator, and trust, where we already saw the ultimatum, but we'll look at a lot of variations of that. And then we'll look at centipede and gift exchange. Actually, one of the first and foremost games that you will learn in game theory is the ultimatum. And so here I even write this in this abstract form. So C is cooperation and D is defect. And then so you would get payoffs HS, both getting H, which is a high payoff if both cooperate. If both defect, you get a low payoff. Of course, the problem here is that there's a temptation that if you know your opponent is cooperating, your defection will give you a even higher payoff than the high payoff, T. Although your opponent will get screwed, so get a payoff of S. So that's very low. This is a dilemma because the Pareto dominant choice is usually for both to cooperate. Defecting is beneficial for yourself. You are weighing against your altruism, how much you regard the other person's welfare versus your own benefit. Do you care about the other guy being screwed for you by your defection compared to your gain from this defection? So how high is T greater than H compared to how low is S compared to H? And in fact, if you learn in the first class of game theory, you should learn that for both players, there's only one dominant action, which is defection. So the only Nash equilibrium here is for both to defect. Well, the theory says there's only one equilibrium, everybody defecting. So what does the data tell you? Well, one-shot games results show that, well, half of the people choose to cooperate. Maybe, or maybe it's that our assumption that people don't care about other people's payoffs is empirically wrong. So if I lower the benefit for defection, well, that increases cooperation. And in fact, if I change the harm, that will also change people's behavior. So people are responding to incentives, but it's not the case that I do not care about other people's payoffs. Having the two parties either meet each other or have a time to chat or even chatting online helps increase cooperation. However, this one-shot behavior sort of deteriorates if you play several rounds repeatedly. So you even if you start out having half of the people naively thinking that people cooperate and they cooperate then, but the other half defects and they get mad or something. But as you see the time series, well, cooperation goes down. If you go on, instead of just, so the Prisoner's Dilemma has only two people. But if you have, say, more people, then you can think of what we call the public goods game, or the volunteer contribution of public goods. So here you have n players, each have an endowment EI. Of course, the simple case would be everybody having the same endowment. It could be that I have rich and poor people. I can change the income distribution. And you have to decide out of your endowment, how much do you want to invest? And then your payoff is your endowment minus how much you contributed. And then what's going to happen is that, so the experimenter will multiply the total contribution by a factor of m and equally divide it across everybody. Everybody's effort is pulled together, but it has to be equally divided by everybody. And so there's an incentive for you to free ride and say, hey, yeah, well, I don't care about the dum-dums who contribute, but if I decide to contribute 0, well, I still get to free ride other people's contribution. And so, yeah, so maybe if I'm self-centered, if I'm a sociopath, I would decide I'm going to not contribute. This is literally the Prisoner's Dilemma. Everybody doesn't contribute, and so, so nobody gains from this. At some sense, global warming is like this, right? Should we cut down our pollution emissions, our carbon emissions? Even if Taiwan cuts our carbon emissions by half, will that affect the fate of global warming? China keeps burning coal and and polluting like crazy, there is no benefit for Taiwan to cut carbon emissions. So the first thing is that theory predicts that if you're self-centered, well, you would decide you want to free ride everybody else, and everybody doing that, so zero contribution is what theory predicts. The one-shot baseline result shows that, well, average contribution is 50%. Well, of course, this is very diverse. A lot of people contribute zero, a lot of people contribute a lot, everything, but it's not the case that everybody is contributing zero. If I raise the multiplier that's applied to the contribution of the public goods, well, people are more willing to contribute because at least I know, okay, so remember, my payoff is, it depends on this m. M divided by n is smaller than 1. Otherwise, I will be very happy to contribute everything because I lose by a fact, I pay by a factor of 1, but my rate of return is m divided by n, which if this is above 1, then I get positive benefits. My own rate of return is 0.9, close to 1, versus 0.1 wouldn't make a difference. 0.1, I would say, forget it. I don't want to contribute. But if it's 0.9, well, at least some people might be willing to sacrifice their own benefit. And so what this means is that given the price of this contribution, well, people do respond to the price. People are price sensitive to this public gain contribution. And so it's not the case that people do not respond to incentives at all. It is, people do respond to incentives. It's not the case that people are self-centered and do not consider other people's payoffs at all. And just like in Prisoner's Dilemma, pre-play communication does help. And, but again, so under random matching, well, contribution just starts from 50% and starts to drop. So yeah, but here's the fun thing. So people actually ran this and said, how about this? Let's add a punishment at the very end. So after I show you the overall contribution and each person's individual contribution, you can decide, do you want to pay $1 to punish one of your partners? It's actually detrimental because you're losing money, even though he or she is losing money. Well, so what? So if you're self-centered, you would not want to do this. What is more, even if you're purely altruistic, you still don't want to do this. Right? This is like sabotage, right? I'm throwing money in the water so that you lose money. And so if I'm only purely altruistic, that I want to maximize the sum of our payoff, I'm reducing the sum. It's only when I have negative reciprocity, thinking that you contributed zero, I want to punish you for that. Would I be willing to actually pay $1 so that you lose $3? So the theory prediction here is that if the self-centered assumption or a joint max or simple altruism assumption is correct, this punishment would never take place. And so the outcome of the first stage will have no difference. Even if you want to punish. Well, here we're allowing for individual punishment. So what this means is that anybody can punish anybody. So at some sense, punishment itself is also a public good. As long as somebody is policing everybody and punishing whoever is not contributing, that's enough. So this is a public good game of a public good game. And also, there's very interesting behavior across groups if you do this across the same group again and again, because people actually do respond to other people's contribution. Let's look at what happens when you add this punishment. So, okay, the first 10 rounds is the standard public good game. You start so that you have an endowment of $20. You decide how much do you want to contribute. Average contribution starts around 10, and then but starts to decline across the 10 rounds. Starting from round 11, now we have ex post punishment. boom, and then it goes up to almost full contribution. Somehow, punishment or negative reciprocity is so personal that you don't care. Because of this, contribution rate does jump and actually converges towards full contribution. The simple assumption of self-interest or selfish or non-other regarding preferences is wrong. So what you need here is specific utility functions where you do take other people's payoff into account. So this is what we call other regarding preferences. So for example, you can have a very simple, dumb example. Just put in your opponent's payoff multiplied by a factor alpha into your utility function. That could be something. And of course, if you have that in mind, you can easily explain why people want to cooperate in the prisoner's dilemma. Because I'm considering C plus alpha times C versus if I defect, I get T, but plus alpha times S. And so if my gain in defection does not outweigh the loss or the harm that I impose on the other person, then I would want to cooperate. So okay, so and of course this depends on your alpha. So this tells you why people respond to changes in the payoff, because some people have higher alphas, some have lower alphas. So you could imagine some of the people that have intermediate alphas will actually switch when I change the parameters in this game. However, one thing here is that it does not account for reciprocity. I'm caring about a weighted average, a weighted sum of our two payoffs. I would not want to punish you. My punishment is going to lower my payoff. It's also going to lower your payoff. So this simple model would be able to explain some of the cooperative behavior, but it would not be able to explain revenge. What I care about is I hate to see, or enviness. I hate to see you getting more money. Yeah. So you can imagine if some people come in and my only goal is to beat my friend who also came to my experiment, then his utility function is xi minus x minus I. So then I want to maximize how much I beat you. That's possible. So you could see this kind of competitive thing going on. But wait a minute. Think of the public good game, sort of a punishment experiment. The result is that now you get to full cooperation where everybody's getting a lot. If you are a competitor here, you would not want this to happen because then everybody's getting a lot of money. You really want something like everybody else getting very low, but you are benefiting. And so you will definitely free ride from other people's punishment. And depending on how other people are doing, what you definitely want to do is to start a free ride at the beginning, so that so you are benefiting, but the other people are screwed. And yeah, maybe you want to defect all the time just to make sure that you are getting more than the other side. Okay, so one of the most well-known, especially in the European continent, is the inequality aversion, or the first Smith model. And the idea here is that, okay, so I care not only about my payoff, but also two things. One is, am I earning more than everybody else? And also, how much am I earning less than everybody else? So the first factor is somebody else earning more than I am. So this is envy. And the other is if I am earning more than somebody else. So that's guilt. So here I feel guilty. So it's a negative beta if I'm earning more than you guys. And also I envy you if you earn more than I do. So here, this is what we call inequality aversion, because deviating from equality always lowers the utility of this person. And one assumption you can make here is that envy is stronger than guilt, so that beta is smaller than alpha, because the emotion of envy is stronger than well, okay, so it's less okay for you guys to earn more than I do compared to me earning more than you guys. Yeah, that's the envy more stronger than guilt. And also, we want this to be less important than my own monetary payoff. So beta has to be zero, between 0 and 1. And with this, of course, here this is what we call inequality aversion. So I want to have I want to preserve equality. Of course, this would explain both cooperating, because now CC is the equal payoff. So there's no equality here. It could explain why some of these contributions in public good games are so different. Some people contribute 0, some contribute a little bit, some contribute a lot. You can use this to explain that. And what is more, this model can explain punishment. You are the defector, right? So you are earning more than I am. So I envy you. So in order to reduce this inequality, even paying $1 so that you lose $3, that's sweet revenge to me, or to this person who has this utility function. So you need some kind of utility function like this to actually get this kind of negative reciprocity, or actually, so here it's revenge, because I'm mad that your free riding is creating an inequality here, and so you're earning more than I am. I don't like that, so I want to punish. So before I go on, so here this is purely a preference on the final distribution. It's not really about the intention. It's not just because you contributed less, so you free rided, so you are earning more, and I don't like this. So it's like Thomas Piketty. Yeah, so I hate inequality, so I want to try to make things more equal. And it happens here that the punishment in the public good game is a way to equalize things, even though it's actually detrimental. I'm reducing my payoff, but I'm also reducing your payoff more than how much I lose, and so this actually lowers the inequality, and so you will want to punish. However, this may not be the right thing, because it could be the case that you want to take into account other people's intentions and not just the final outcome. Professor Chunlei Yang in Seneca is one of the experts who ran a lot of prisoner's dilemma experiments. And Professor Xu Lizhen in National Zhengzhi University is an expert on doing public good game experiments. She has run a lot of these to study public finance and taxation. And in fact, the speaker this week, okay, so up to here, what I want to show you is that it's not that theory is wrong, it's that these results are inviting new theory to explain what you see. What we will see here is what we call social preferences. The utility functions I listed are also listed in the textbook, section 2.8, where Colin talks about a lot of these different things. I will try to highlight these along the way. But one problem for these games is that defection is a dominant strategy here. So dominance could explain all of this. And also, you cannot really distinguish between what we call conditional cooperation versus pure altruism. So in the standard public good game, responses are diverse. What you do see is that there are 1/6 of these people are always cooperators. So these guys contribute no matter what. 1/6, so 16% are always contributors. There's 1/3, so 33% roughly, are free riders no matter what. But the remaining 1/2 of the subjects are what we call conditional cooperators. So it's like this. It's like if you know that everybody's contributing, you feel guilty not contributing. But if you think that everybody else is not contributing, you don't want to be the dum-dum that's contributing. So this is what we call conditional contribution. And it is this effect that results in the decline in cooperation, in contribution, starting from 50% at the beginning and then dropping down, because people start to realize that their expectation of how much you want to contribute is not fulfilled, and so they say, oh no, I don't want to be the dum-dum, and you start to drop out. However, the simple model that we saw here, even the first Smith inequality aversion model cannot account for this conditional cooperation. Well, you only care about the final inequality. The problem here is that it can only take into account the difference in the final the final payment distribution or the income inequality. It cannot take into account your belief about whether or not other people are contributing, because there's nothing here about intentions. One possibility is to look at games where there is no dominant strategy. So here, for example, the ultimatum game. The key thing here is that here it's no longer the case that one strategy is dominant from the other. And so usually we have the baseline, which is a one-shot, anonymous, and what we call the action method. So that's the baseline. So you have only one chance to split $10 and accept or reject. However, it's very costly to do this, right? There's only one chance. You get only one data point. And what is worse, you actually don't see the whole strategy of the receiver. Why? Because if I give you a 50-50 offer, as you accept it, I do not know what would you do if I give you a 40-60 offer or 30-70 or 10-90 or whatever. One way to fix this is to run this repeatedly under random matching, so that I could see you as a respondent, say 10 times, and see how your behavior changes across different offers. That's one way. However, this is not ideal, especially if most people are offering 50-50. Then even if I see 10 different offers, well, I still may not be able to observe what you would do if you face a 20-80 offer, for example. So instead, another way to do this is to do the strategy method. I ask the responder, instead of showing the actual offer, I ask you, what is your minimum acceptable offer? What's the lowest you're willing to accept? And then to make this real incentives, what I do is I take your minimum and then compare it with the actual offer. If the actual offer is smaller than this, then I reject it for you. If it's above this, I accept it for you. So it's like, so I ask you a minimum, so it's like asking you to program this, your robot to make the choice for you. So strategically, this is the same game, because but I can elicit your actual strategy. What is your cutoff? What is your minimum acceptable offer here? In that case, I can overcome this non-observation problem, that if I just show you a 50-50 offer and ask you, do you accept or reject, I do not know what would you do if the offer was 40-60, 30-70, and so on.
But what if the responder lies?
Well, I don't care, right? I mean, you can say 50-50. But anyway, when the actual offer arrives, it's 49.51. I say, too bad, it's below your minimum, so I reject it for you. So that's your outcome for this period. So yeah, so you can misstate your minimum acceptable offer, but you have to pay the consequence. You have to bear the consequence. You would have wanted to accept, but you lied, then the computer will reject the offer for you. And so you will have to accept the consequence of both getting zero. Yeah, that's part of the smart way. Why instead of just asking you, I actually tie your answer to the outcome, to the real consequence. That's why this is a real incentive here. However, of course, empirically, whether or not people's choice, when asked this hypothetical minimum acceptable offer, or actually not really hypothetical, but so this the strategy method versus when I actually show you an offer of say 3070. Are you willing to accept? Well, empirically, whether or not this is the same is an empirical question. And one problem is this. So think of this. I mean, if I show you a 3070 offer in front of you, are you willing to accept $30? Versus if I ask you, from 0 to 100, what's your minimum acceptable offer? Well, it could be the case that seeing a 3070 offer is so, you get so pissed off by this unfair offer that you decide to reject, compared to when you're asked, so what's your minimum number that you're willing to accept? But it could also be the case that seeing $30 here and saying, what if I give up this $30? No, well, I can pocket this and buy something for myself or something. So you could actually be willing to be more willing to accept it when you actually see the real offer, compared to when I asked you in the strategy method. But of course, this is an empirical question. So yeah, so that's something that I think only data can tell. All right, so if you want to look at the result, I have to tell you that I cannot summarize the result in one slide because there's so much. Well, the first automaton game experiment was ran in 1982. There are actually two tables, actually multiple pages in the textbook trying to show you the results. Actually, on the website, I actually give you 3 review articles, one reviewing a whole bunch of automaton, actually dozens of automaton game experiments. The second review paper on more than 10,000 observations of the dictator game. And then the third paper, another dozens of articles on the trust game. So there are so many replications or different variations of this game. But okay, so let me give you a sense of the data. So the mode is 50-50, and the median is between 40 to 50. Although the mean is 30 to 40, so there's a tail of low offers, but very few sort of ultra generous offers where I give you more than half of the pie. Almost nobody gives above 50 or below 10. One problem here is that, is this because of fairness or a fear of rejection? Because if you look at the respondents, well, 40 to 50 offers are almost always accepted. But when you go down to 20 or below, then the rejection rate is is more than 1/2. So you do see that people reject low offers, and so it could be the case that the proposers are proposing these 50-50 or 40-60 offers because they're afraid to be rejected. Well, if you want, you can write a simple first model to explain this. Why is that? Because, well, if I have inequality aversion, well, seeing, say, 2080, this gives you $80. I get only $20. I get so mad. I envy you so much. I decide that that's bad, and it's even worse than both getting 0 with the right alphas here. Then. Yeah, so then I could be so envy about you earning so much, 4 times more than I am, so that I get so mad that I decide to reject you. Yeah, that's one possibility. Of course, that depends on how inequality averse you are. And also, if you are the proposer, well, proposing 50-50 means that you will not feel guilty that you are earning more than the other side. And so that could also explain proposing 50-50. Well, of course, one problem here is that with the simple altruism model, so I care about your payoff, monetary payoff multiplied by alpha, this model would not be able to explain rejections in this game, because even if I see a 10-90 offer and if I reject it, it's like punishment in the public good game. Well, so both of them are getting 0. So my utility is 0. plus 0 times alpha, it's 0. Compared to that, getting 10 for myself and getting 90, unless I'm spiteful with a negative alpha. Otherwise, I would not be able to explain this kind of rejection. But if I'm really spiteful, I should reject everything, right? I only want to maximize the difference between my payoff and your payoff. Well, both getting 0, we have no difference. But 50-50, well, we have no difference. So I should also randomly reject 50-50 offers. Or like, how about 49 versus 51? Well, so it's slightly unequal. And but then if I'm really spiteful, I should say no. If you earn $2 more than I am, I'm really mad. So I want to reject because if we both get 0, then the difference is 0. If I only care about the difference, I should do that. Of course, we don't see people, most people do not reject, say, 40-60 offers. Of course, this is not the only model that you can explain this. There are alternative ones. For example, this is what we call the ERC model that takes into account envy, reciprocity, and competition. So it's the relative share of the pie. So compared to what everybody earns, so what fraction do I earn? So here the relative share is what's important here. But one problem here is that it's only so with respect to the whole pie. So with only 2 players, it doesn't matter. But if we have, say, more players, then things could be different. And yeah, so one thing you could try to do is to use this to explain what you see in the prisoner's dilemma and the ultimatum game. But the next question is, wait a minute. So suppose now we have two proposed model. One is the ERC. The other is the guilt envy model that we saw previously. What kind of game can we design to run an experiment to tell which model can explain more data compared to the other model? Looking at punishment and rejection tells us that the pure altruistic model is less useful to explain data compared to the guilt envy model. Now I'm going to move to the dictator game. The dictator game is an ultimatum game without rejection. It's just that the proposer proposes a split, and that's it. It's automatically accepted. Well, what this means is that now there's no fear of rejection. So whatever the outcome is must be pure fairness, pure altruism. And if you look at the data, actually, again, we have too much data to summarize in any slide. What you do see is that, yeah, so this pushes the distribution down. So the offers are less generous than the ultimatum game. So you do see there is a big role of why the majority of people propose 50-50 in the ultimatum game is because of the fear of rejection. However, it's also not the case that everybody's proposing 0. And so you do see that it is true that people do have other regarding preferences. And so, yeah, so what this means is that both altruism and some strategic concern about the fear of rejection does have play here. Although it is true that, well, in some sense, people are too pessimistic. Because proposing 50-50 is almost surely accepted. But so is 40-60. So you could actually gain a little bit more if you make it a slightly unfair but not too unfair offer. But apparently the proposers are not doing that. So it's as if they are so afraid of rejection here. Or it could be that people have a true preference of equal split. One problem to explain this result is that with the guilt envy model, well, because it's linear, you would either give 50-50 or give nothing. Why? Because if you care about inequality so much, you should do equal split here. But if you don't care about that much, then you should just go everything for yourself. Yeah, so you might be able to fix this by introducing some convexity to your utility function, but that's too mathematical for this class. So if you want, you can try that. But of course, you can imagine you can use other models to try to explain this.
Or maybe you meet the other subject after the experiment.
Yes.
And you see in the pocket that people have money, but that maybe the others doesn't have.
Yeah, so, and you might actually meet the other person before or after the experiment. Well, of course, this is an empirical question, right? You could try to run an experiment where, say, the two parties never actually meet in the same experiment. Of course, it's a little bit tricky. How can you not have even the experimenter know that who are the assholes who do not give anything to the other side? That's a design challenge. How can you do that? But this is a possible concern, that it's not about me caring about the other party. It's me caring that the experimenter is looking at me that's causing this behavior. And of course, in the next lecture, I will try to show you how some of the experimental economists try to address this.